Hello, finally onto section B, which is the more long form questions. This is worth quite a fair bit, isn't it? 8 and 3 is 11, 16 marks just in this particular question. Oh, there it is there. So again, I'm focusing on calculator usage and just wanted to point out that this question here is a finance question. It's also just a sequences and series question, depending on how you see it. So you've got two friends, Amelia and Bill, each set themselves a target of 20 grand. They have $9,000 to invest initially, and then there's some set conditions here. Pause the video and have a read through it. Okay, hopefully you did pause that video. Now, you could approach this in two ways. You can just use the compound interest formula or use some sort of geometric sequence in order to solve this. You would use your calculator because the numbers are all complex and you will get the right answers. And when you see the mark scheme, you'll see that you can do it that way. But what I really wanted to show you is that there is a financial solver or a finance solver in your GDC that you can use to solve these problems fairly straight. Well, I think it's kind of straightforward. So here's where we go. So from, you've got a calculator up, and from the menu button, you go down to finance, and there's a finance solver. Okay, I'll just delete this because this is kind of what I was just practicing before I started here. So this is how it kind of normally starts. So N is the number of payments. I is the number let's just do it. So Amelia invests her $9,000 in an account. So the $9,000 is here, which is the present or principal value. So 9, 1, 2, 3. It offers 7% per annum. So you have to go up to the I and type in 7, not 0.07, but the actual percentage itself, 7% per annum. It's compounded annually, and what that means is, can you go see down here, it says PPY, that's payments per year. So you leave that as one payment per year of interest. And compound periods is once per year as well. Okay, so you basically fill that in. It says find the value of Amelia's investment after 5 years to the nearest $100. So that means that I am going to be sort of, they're going to be making a payment 5 times, right? Once every 5 years. For 5 years, so you got n equal to 5, and it says what's the value of the investment. So that's where you go down to FV here, future value, and if I press enter, it should give me. I've done something so I cleared everything out. I think the payment's supposed to be 0 here. And then the final value, it now says press enter to calculate the future value. Press enter. And it's a bit weird. It gives us a negative here, which you can basically ignore for this kind of problem. So it's 12,622 point blah, 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 blah. So it does say here to the nearest $100. So it's going to be minus $12,000 is the final value. But you would write $12,000. The reason why it's negative is because this finance solver is designed, although you can use it to work out how much you're going to earn over a period of time, it's also designed to put in payments so that if you're paying off a loan, for example, and you say, if I pay off $100 per year, how much will I owe at the end? And it will be able to calculate it all for you. So we're kind of using it in a bit of a weird way, slightly, I suppose, but it still works. You just got to note that the minus 12,000 is kind of like the bank will pay $12,600 to you. So this is from the bank's perspective, it's negative. And you can see it here. I shall flick over to the mark scheme, and you can see that it says either, and this is like the compound interest formula or a geometric sequence, and it gets you that number, or, and see what it does, you write down what you see here. Well, the critical ones don't have to worry about payment of 0, but n equals 5, I equals 7, PV equals 9,000, and you can see it's got the minus plus there. Payments per year is 1, compound per year is 1, and you can see that it says plus minus 12,622.965, that's what we've got here, and so the answer is $12,600. So that's what you would write down to the nearest $100. So it's literally just doing that. Okay, let's do this a little bit faster for this one. Determine the number of years required for Amelia's investment to reach the target. Remember, the target was $20,000. So we go through this again, and we will remove the minus 12,000, and we'll put minus 123 minus $20,000. Then I'll just use the tab key to cycle my way through here, and it'll go up to the top, and I am going to press enter to calculate the number of payments, and press enter, and I get 11.8. So by the 11th year, I wouldn't have enough money, or Amelia won't. By the 12th year, she would. So again, looking at the mark scheme, we're putting in the values that we've given, and then you can put down the output value of 12 years. So once you've got the information in once, it's kind of useful to be used over and over and over again. Bills invests $9,000 in an account that offers an interest rate of R%. We don't know R in this instance. And it's compounded monthly. So we get the interest rate per annum compounded monthly. So I'm going to go straight down using the tab key here, straight down to payments per year is still 1 because it's per annum. And here I'm going to put 12 periods per month. Sorry, 12 periods per year because it's monthly. If it was daily, it'd be 365.25, I think, or 365, I can't remember. If it was quarterly, it would be 4 times a year, etc. Anyway, it's 12 because it's monthly. Then let's see what happens for the rest. $9,000 was invested, so the PV is 9,000, that's fine. So I've filled in everything I can at the moment. Find the minimum value of R needed for Bill to reach the $20,000 target. Okay, well, I've got my $20,000 in here already, so that's good. Principal, present value of 9,000. So I think I got everything I need to work out R. So I deleted it, what was in there, and now it says press enter to calculate the interest rate. So I'm going to press enter, and it gives me 6.7849. Does it say how many decimal places? R is set to 2 decimal places, so it should be 6.78. So look at the mark scheme, and we've got 8.02. What did I do wrong? Oh, I didn't change N. So N is supposed to be 10 years, and now we'll work out the interest rate, and it's 8 point. Now it says 8.0117 here, and I'm not too sure why it says 8.02. You can see this, the answer is right here, 8.01170. Oh, I can see why. So if I went to 8.01, that would not quite get me to $20,000 by the 8th year. So by the 10th year. So I need to round up to 8.02 in order to get to the $20,000. So you've got to be careful. You don't just use your standard rounding rules. Think at the context of the question. Okay, so hopefully that makes sense to you. Now, C, I'm not going to go through. You will use your calculator in a fundamental way to solve problems for part C, but it's actually not using the financial solver. Very briefly, I'll get you to pause the video and read C. Okay, hopefully you did that. So Chris is because he's going to halve his amount of money each time. It basically works like a geometric sequence or geometric series, to be honest, because you're going to be adding up all the amounts. And it effectively goes. Part 1 says show that Chris will never reach the target if his initial deposit is $9,000. So that's an infinite series. He will never reach it if after an infinite number of payments he's still not getting to $20,000. Part 2, it says find the amount that Chris needs to deposit in order to reach the target after 5 years. So looking at the mark scheme really quickly, we can see R is a half because he's halving it every single year. So the sum to infinity will go to $18,000. So therefore he'll never reach the target. And for part 2, you look at the geometric sum formula for $20,000 and solve for U sub 1, and that'll give you $10,323. So that's how you do that particular problem. I'll leave that there, and I shall do another video in a tick.